All right, so now we're going to take a look at probably one of the most important tools that we have in chemistry, which is the periodic table. And we are going to, from this point onwards, abbreviate periodic table as PT, just to save on time. And the periodic table is, for our class and for any chemistry class, is really going to become your best friend because there's a lot of information that is embedded in the periodic table that we can extract if we understand how it's arranged and how it's organized. So obviously, when elements were being discovered way back when, people naturally tried to organize the elements in whatever way they could. And scientists at the time had proposed different ways in which to organize the periodic table. And we'll take a look initially at some of the ways by which different scientists attempted to do that, attempted to arrange the elements, organize them in a way that made sense. Now, just to back up a second, in the previous section, we talked about and we used hydrogen as sort of our basis for the understanding of the atom and the electron in general. We're going to continue that discussion in this section when we start looking at now multi-electron systems or multi-electron atoms, multi-electron ions, etc., when the situation now is going to become a little bit more complicated because now we're dealing with more than one electron rather than one electron in hydrogen. But as we're going to see, there are things that we can use, different trends, etc., to help us predict some of the properties of these different types of systems. So let's take a look, first of all, at some of the early developments in how the periodic table was organized. So it started way back, just before the turn of the 20th century. Newlands noted that there was this repeating or periodic occurrence of properties when the elements were organized in a particular way. Now, around that same time, a couple of other scientists, Dmitry Mendeleev, and Lothar Meyer, both also independently had proposed the idea of periodicity. And essentially what that means is that when the elements are arranged in a particular way, they have properties that recur or that occur periodically. Okay, so when the elements are arranged in a particular order, their properties recur or occur periodically. So what does periodically actually mean? Well, if you think of as an analogy, if you think about the keys on a piano, okay, you have the notes that sort of repeat themselves every so often in a periodic pattern on a piano. Well, it's the same kind of idea with the elements when they are arranged in a particular way or in a particular order, their properties or their characteristics, right? So properties, remember, is just another word for characteristics. Occur or recur in a periodic or predictable or a repeating pattern. And based on this observation, scientists at the time were able to predict the properties for elements that had not even yet been discovered, right? So today we know 118 elements. At the time of Mendeleev and Meyer and Newlands, there were only maybe a third of the elements that were discovered at the time. However, based on this periodic pattern, this periodic law, they were able to predict some of the properties for elements that they hadn't even discovered yet. And this is one of the hallmarks of the periodic table today, even, is that it's very predictive. Okay, so that's an important property of the periodic table, is the fact that it is predictive in nature. just based on where the element is on that periodic table. Okay, and this is it's a very simple idea, but it's a very powerful idea as well. So Mendeleev at the time, he arranged the elements, or he organized the elements by order of increasing atomic mass. We talked about atomic masses in previous sections. Now, even so, he was able to observe these periodic properties. However, there were some inconsistencies in some of the properties of the elements, even though generally they held true. There were some inconsistencies. And what they actually discovered was that instead of arranging the elements by atomic mass, by increasing atomic mass, instead, if you arrange them now by increasing atomic number, and if you recall, atomic number is the same as the number of protons. Was way more predictive or periodic, I guess would be the term. So in other words, there weren't those discrepancies that Mendeleev had observed early on when he arranged them by increasing atomic mass. So up to today, our elements on the periodic table are arranged by order of increasing atomic number, which is, again, just the number of protons that we have in the elements. And as a result of that, we're going to see there's a tie-in, or there's a connection between the number of protons and by arrangement of their electrons as well in their what's called the electron configuration. And we're going to take a look at in a lot of detail about that. So if we take a look at a periodic table today, the most up-to-date version of the periodic table, what we will find, starting with hydrogen up here on the left side and working our way across, we will see that there's an organization by increasing atomic number. So remember now, when you see that entry in the periodic table, such as this, that we have for hydrogen, we have your symbol for the element, the elemental symbol. We also have the number on top, which is the atomic number. Okay, and the atomic number is how the elements are arranged by increasing atomic number. So we have atomic number 1, we go from left to right, helium, atomic number 2, and then again, starting on the left side, lithium 3, beryllium 4, boron 5, 6, all the way over to 10, and so on and so forth. Remember also the number underneath, right, usually a decimal, that is the atomic mass. And generally, we're going to see the atomic masses increasing in the same pattern as the atomic number. However, there are going to be some discrepancies, which again, it harkens back to some of the earlier attempts at arranging the periodic table. So we're not going to see a strict increasing atomic mass as we do an increase in the atomic number as we go across and down in our periodic table. So just, just keep that in mind when you look at your table. The main thing you want to focus here is that it's arranged by increasing atomic number, which is the number of protons.